Here is my Renogy Eclipse 100 watt portable solar panel, which is a folding suitcase style. I only use it when I'm camping in order to double up my solar power to 200 watts. I use it with a 20-foot solar extension cable and branch connector, which allows me to connect my two solar panels in parallel. Here is my Renogy Eclipse 100 watt solar panel, which is permanently mounted onto the roof of my 4Runner using custom-made aluminum mounts connected to the factory roof rails. I also made custom support bars to raise the angle of the solar panel to approximately 30 degrees in order to maximize the solar input. Of course, when I am driving, I remove the support bar so that the solar panel is flat and securely mounted on my roof. Here are the two support bars which allow me to angle the solar panel to 30 degrees when stationary. I drilled one hole on each end to allow the threaded rod to pass through the bars at the bottom, then to insert a square lock pin at the top to secure the solar panel. Here's how the solar panel sits when securely fastened for driving. The threaded rod on the passenger side goes all the way through the solar panel, through both brackets, and is tightened using a washer, lock washer, and nut. There's a little bit of play, but it is very secure. I've never had any issues while driving. The custom solar panel mounts were made using 2-inch by 3-inch aluminum angle and are bolted into the factory roof rails using T-bolts with a large washer in between which help tighten them down. I then used 2.5-inch by 2.5-inch aluminum angle to make the solar panel mounts, which are bolted into the main roof rail mounts and the solar panel. For the passenger side, I used a 25-inch piece of stainless threaded rod, then put a lock nut on one end, then washer, lock washer, and nut on the other end. The threaded rod goes through both solar panel mounts and the entire solar panel. It also functions as the base for the two support bars which hold the solar panel up at a 30-degree angle. For wiring, I have the branch connectors permanently mounted on my roof using zip ties to the factory rail when driving. Here I've removed the zip ties in order to easily connect the portable solar panel. I do have a 30 amp inline fuse connected to the positive side of the branch connector, as this is a best practice to prevent damage from any short circuits. The solar panel wiring is then covered in this blue sheathing to protect it as it goes in between the rear hatch and the body of the 4Runner. I then zip tied the wiring onto the factory wiring harness inside the hatch. There is a rubber grommet that brings the factory wiring into the inside of the truck, so I used a knife in order to cut a hole to feed the solar panel wires through the grommet. I then sealed it up with a healthy amount of silicone to prevent any water from getting inside. The wiring then goes underneath the inside roof panels, running towards the passenger side. From there, the solar panel wiring feeds into the solar input on the Victron solar charge controller, which is mounted using an L bracket and plexiglass screwed onto the side of my custom-built drawer. I have the 100/20 model, which can support up to 100 volts and 20 amps. It has built-in Bluetooth, and configuration is easy with the Victron Connect app for your phone. There is a separate load output connection, which I've used to support two 12-volt cigarette lighter connections, one being used for my 12-volt fridge. The Victron MPPT will automatically adjust the solar input if there is a draw in the load output, meaning that it will increase the watts being drawn to support both the current charging state and the load output. I ran the battery wiring underneath the plastic trim by the doors, then up through the passenger side firewall. There is a grommet on the firewall for brake lines that I use to run the battery wires through in order to get them into the engine compartment. There is a common ground used for both of my batteries, with it running to the starter battery. The positive battery cable for the solar charge controller is connected to a 25 amp circuit breaker fuse to prevent any damage from short circuits. Here's my Victron SmartShunt rated for up to 500 amps, which measures all charge and discharge from the battery. With the SmartShunt, you have to connect the negative terminal on your battery to one end, then all the negative connections to the other end in order to properly measure the battery. The SmartShunt has built-in Bluetooth and is easily configurable through the Victron Connect app on your phone. My dual battery is made by Full River Battery, being a 105 amp hour AGM. Here's the Victron Connect app, which I have installed on my Android phone. Once you open it up, you have the option to connect to different Victron devices. Connecting to the solar charge controller, the status tab shows us how many watts are currently being drawn from the solar panel. Under solar, it provides the solar panel voltage and solar panel current. Under battery, it shows battery voltage, current, temperature, and charging state. Under load output, it shows the state as on or off, current, and power being consumed by the load. The History tab allows you to see historical data for the amount of time spent in the different charging states, total solar yield in watt hours, Pmax for the solar panel, Vmax for the solar panel, as well as maximum battery voltage, minimum battery voltage, and total consumption in watt hours. Clicking on the cog wheel on the top right-hand corner brings you to the Settings tab. From here, click on Battery, and you can adjust the voltage for your battery or battery bank. You can also adjust the maximum charge current, enable or disable your charger. Disabling would be used for performing maintenance. Clicking on the battery preset option allows you to use the Victron default or presets based upon the battery type. I have used user-defined as it allows you to customize the charging profile for your battery to exactly match the manufacturer specifications. I also enable expert mode as it provides you with more options. As per my battery's manufacturer, I have the absorption voltage set to 14.7, float to 13.65, and set equalization to match absorption at 14.7. The rebulk voltage offset is set at 1.65, meaning that in float charge, if the voltage drops down to 12 volts, the charge cycle will restart. My absorption duration is set to fixed to 4 hours with a tail current set to 1.8 amps. For the equalization settings, I left them as is, except that I disabled the automatic equalization as it is not recommended by my battery's manufacturer. I set the temperature compensation to minus 24 millivolts per degree Celsius. I disabled the low temperature cutoff, which would be typically used if you had a lithium battery. I would highly recommend reaching out to your battery's manufacturer when adjusting any of the battery settings within the Victron solar charge controller or the SmartShunt. Going into load output settings, you can configure the operation mode in order to prevent excessive discharge of your battery. When in the spring and summer months, I always leave it as always on unless we are experiencing a string of overcast days, then I will use a preset voltage cutoff as to not over discharge my battery. Going into VE Smart Networking options, you will see the Victron network that you have created if you have multiple Victron devices that are communicating with each other. Here you can see that my solar charge controller is using the SmartShunt for battery voltage, battery temperature, and battery current. The other solar charge controller settings such as street light, TX port function, RX port function I left as is and did not change. Opening the SmartShunt in the Victron Connect app, the Status tab shows state of charge as a percentage, with 100% being fully charged. Then under Output, it shows the battery voltage, current, power, and consumed amp hours. Under Input, it shows the battery temperature. Clicking on the cogwheel at the top right-hand corner brings you to the Settings tab. Clicking on Battery allows you to adjust the battery capacity in amp hours, charge voltage, discharge floor, tail current, charge detection time, Peucard exponent, charge efficiency factor, current threshold, and time to go averaging period. Peucard exponent. Capacity of a battery depends on the rate of discharge. The faster the rate of discharge, the less capacity will be available. The relation between slow or fast discharge can be calculated by Peucard's law and is expressed by the Peucard exponent. On Victron's website, you can download a Peucard exponent calculator, which requires you to enter different discharge rates provided by the battery manufacturer. Other battery settings include enabling battery start synchronized, manually setting the state of charge, synchronizing the state of charge to 100%, and performing a zero current calibration. Under the alarm settings, you can set up alarms for low state of charge, low voltage, high temperature, and low temperature. Under the miscellaneous settings, you can adjust the monitor mode, auxiliary input, and temperature coefficient. Going into VE Smart Networking, you can see that my SmartShunt is transmitting battery voltage, battery temperature, and battery current to my solar charge controller. Victron has detailed manuals online outlining each setting for both the solar charge controller and SmartShunt. I also recommend contacting your battery's manufacturer if you have questions, in particular for a solar setup. I hope that you found this video helpful and gives you some ideas if you are looking to add solar to your Toyota 4Runner or any other vehicle.